This question is testing a familiar topic. We're being asked about the number of solutions, and so this keeps coming up. This is something the SAT has been doing more and more of, and it's kind of frustrating because here we don't have lines. Lines are really easy to think about. This is a quadratic equation. We can tell by the x squared that we see there, so it's a little bit more complicated. But hopefully your robot brain for algebra will kind of take over here. We can't do any strategy. We just kind of need to do the math. And what we want for quadratics is everything equal to 0. So we're kind of there, and that's why when we're talking about solutions sometimes with quadratics, we're also talking about X intercepts. So in order to find X intercepts, we normally factor, and we can see that we kind of have things that look like factors here, but it's all jumbled up. The safest thing to do is just to do what feels the most right. In this case, I'd be like, well, I'd probably square this x plus 1 and see what happens. And skipping the foiling here, we would get x squared plus 2x plus 1, right? Because remember, this needs to be FOILed out because it's not like we can just distribute the exponent. We need to FOIL it out. So x squared plus 2x plus 1. This then we just do normal distribution, plus 8x plus 8. Don't forget the 16 that's there. And now we can just start to clean up this side. It's about combining like terms. Well, x squared is just the only x squared, so that's fine. 2x and 8x is 10x. And then 1, 8, 16, that's going to be plus 25, and that's equal to 0. Now we have a much more familiar looking quadratic, and hopefully again the robot brain kind of takes over, and we know that we need to factor this out so that we get those little parentheses terms that look like this. And so when we do that, we're looking for numbers that multiply to 25, add to 10. Well, that's just 5 and 5. So x plus 5, x plus 5. And so we can kind of already see what's going on, but if we were to solve those mini little factors there, we would get that x is equal to negative 5 twice. But look at the question. How many distinct, different real zeros or real solutions does the given equation have? Well, it has two x equals that came out of this because there's two factors, but they produced the same solution. So there is exactly one solution here. This is a little tricky, a little higher level. I like it when we just get asked for the solution and we just kind of already know the robotic part of our brain is just going to factor. Here, though, it's still very robotic. It's very similar to what we do in school. So if you see a quadratic, odds are good you're going to want to get it equal to 0 and then factor the results so you can get the answers. The same thing happens here, and then we're just kind of at the end testing how do those two answers relate to each other.